Hello friends, welcome to the demonstration of the project named an interactive multi-touch screen using infrared sensors. This project has been submitted as an entry in TI India Analog Design Contest 2012. We would like to thank our faculty mentor Mr. Sujay Chakravarti and our head of the department Professor B. Acharya for contributing and guiding us throughout this project. We would also like to thank the coordinators of this competition, Mr. C.P. Ravi Kumar and Mr. Sagar Juneja, for guiding and supporting us throughout the contest. Now, talking about the motivation of this project is basically related to the interaction techniques, or simply saying the easy interaction techniques for providing a digital interface to the computer operated devices. As a motivation, let's consider a situation and go into the social aspect. We see that in the village areas and the small towns, the education level is quite low, and this is just due to the less interactive education. That means the education that is presented to the small children is not more interactive anymore. So we need to be more interactive in using the techniques by providing a digital interface. So this project is basically dedicated to the purpose of providing an easy interface to the computer, like controlling mouse pointer and operating the icons, operating images and other controls. The devices and ICs used in our project, borrowed from Texas Instruments, are: first, 8-bit parallel in serial out shift register SN74165. Second, D flip-flop SN74175. Third, tri-state bus buffer SN74125. Fourth, Stellaris ARM Cortex M3 microcontroller in LM3S9D92 evaluation board. Now we come to the hardware section of this project. As we are seeing here, the printed circuit board that you are seeing here is the sensor module. These sensor modules are fit in the periphery of a rectangular panel, say the monitor of our computer screen. These sensor boards actually comprise of infrared sensors, IR LEDs. As you can see here at the front, there are two IR LEDs, that is IR908 IR transmitter, and the black infrared sensors are the TSOP 1738. At the back of the sensor array, we can see that there are some ICs. These ICs are borrowed from Texas Instruments. First IC is a shift register. Shift register in this prototype is used for collecting data from this sensor array. We have used this shift register because, as we can see, that in this panel we are having lots of the sensors connected. The number of these sensors is 96 and the IR LEDs fit on this screen are 24. So we can say that since we are not having much of the IO pins in our controller, you can see here Stellaris ARM Cortex M3 from Texas Instruments. This microcontroller doesn't have much of the IO pins, so that each IR sensor can be interfaced. So we are using shift registers to increase the I/O pins. The ICs that you are seeing here also comprise of D flip-flop and buffer. The use of D flip-flop and buffer is to provide on-off pulses to infrared LEDs. In this project, actually we are using these IR LEDs and we are switching one by one each LED on and off, and for this purpose we are using D flip-flop and buffer. Now let's have a brief introduction to the working of this module. First of all, the first part that comprises this project is the data acquisition part. The space that we are seeing between these two sensor arrays, the first one is this and the second one is this, and the space between this is sensitive to the human touch. Suppose a person touches in this point, so the infrared rays coming from the infrared LEDs will be interrupted and the corresponding outputs of the IR sensors will change. So this data appearing at the end of the sensors will be transmitted to the microcontroller, as we can see here, and from the microcontroller through the USB interface the data is getting transferred to the laptop. Now this data is useful for creating scan lines in an image. We will see in our further steps of our presentation what are the scan lines in the images. Now the images created by the scan lines will be further used to make a video that will be interfaced to a image processing software called Community Core Vision, and we will be implementing TUIO mouse driver for controlling the mouse positions on the computer console. So finally what we will be having is a moving finger on this space will create the corresponding movements in the mouse pointer on computer screen. Now we come to the software implementation of this prototype. We can see here that the frames of AVI frames of images are being converted to AVI video format. You can see that there is written number of frames in AVI out file is equal to 5. This software is interfaced to the microcontroller using USB and is implemented using libusb.h library file. Now after the conversion of frames into video, that is AVI format video, we will be using this video to be interfaced with image processing software, that is Community Core Vision. This is the software Community Core Vision, that is CCV, for image processing. The video made in the previous step is now interfaced with the CCV for the blob detection, that is the touch detection. The image that you are seeing here is the image found by creating the scan lines. Each line in this image corresponds a successful communication between IR transmitter and receiver. And in this condition there are no touch points on the touch panel. Now we will show the movement of the blob in the CCV software corresponding to the movement of finger on this touch panel. Now we started movement of our finger on this touch panel. Now let's see how the movement of the finger changes the block detection in CCV software. We can see here that the block on CCV software also changes correspondingly. Now at this stage of our project, we have connected each software, image processing software and the mouse driver, that is TUIO mouse driver, and now we are ready to see the touch detection process. Now I will drag my finger over this touch panel, and correspondingly you can see over here the mouse pointer is also moving. Hence we have seen that this prototype of multi-touch panel is capable of controlling the mouse cursor position on the computer screen. As a future improvement to this project, we can further work on the packaging of this system. As we can see, we can further reduce the size of the PCB of the sensor board, and also we can try to add same panels as fitted in the two opposite sides of this rectangular surface, which are left here, which will definitely increase the sensitivity of the touch detection in between the multi-touch panel. After analyzing this project, we have seen that the cost of the implementation is around 2,200 rupees. If we think of the bulk production, we can further reduce the design cost and the manufacturing cost of this system. At this stage of implementation, though this project is not a good packaging, but it is implementable design for the applications where packaging, resolution, sensitivity are not a big issue. So it is a very good start to the multi-touch technologies, an alternative way which can provide us a cheap, affordable and a feasible design. I think at this stage this is so designed that a common man and a common applications can use this technology for the interactive displays. Thank you.